Good day everyone, and welcome to where we are working on any math or science topics that we are getting problems with. In this video, we'll be concentrating on the past paper questions on the CSEC Mathematics topic of trigonometry, and specifically dealing with any trigonometric questions on right-angled triangles. The past papers that we'll be looking at will be over the years May 2015 up to May 2021 in paper 2. Feel free to like the video and add any comments down below so we can help you in any area of math or science at both the CSEC or CAPE level. Let's look at the topics in CSEC Mathematics, and we can see there's a list of up to 10. Topics are from 1 to 9, and number 10, investigation, is a combination of any couple topics from above. We will be looking in this video at specifically number 8, geometry and trigonometry. It is a huge topic in CSEC Mathematics, as it is worth 8 marks out of 60 in paper 1, the multiple choice, and 21 marks out of 100 in paper 2. Geometry and trigonometry can be subdivided into geometry by itself and trigonometry, of course. And trigonometry itself can be subdivided into two parts. The first being about right-angled triangles, and the second about all other triangles. Right-angled triangles, as we can see from the diagram, there is an angle, let's assume theta, and the longest side is called h, or the hypotenuse, which is opposite the right angle. The side touching the angle theta is, or next to, is called the adjacent side, or A, and the side opposite to it is O. From this relationship, we can find our first formula in this topic, which is Pythagoras' theorem, which relates the lengths of all three sides, such that O squared plus A squared is equal to H squared. And there are three trigonometric ratios that relates the sides, two of the sides and the angle. The first being sine theta is equal to opposite over hypotenuse. Cosine theta or cos theta is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. In looking at the past paper questions over these 7 years, from May 2015 to 2021, we've made some steps for students who are getting problems in this topic. And the first being that when we are looking at this question, we list all the formulae, which are 4 in this case, and then identify which shape is relevant from the diagram that is given. We draw only that shape, and then identify which sides and angles the question uses. Select the formula, then substitute accordingly into it, and solve for the unknown. These steps will help for students who are getting major problems. May 2015, number 10A. The diagram below, not drawn to scale, shows a vertical tower BT. And we have that in brown, with a flagpole TP mounted on it. And that is indicated in red. A point R is on the same horizontal ground as B, such that RB is equal to 60 meters, and the angles of elevation of T and P from R are 35 degrees and 42 degrees respectively. Part 1. Label the diagram to show the distance 60 meters. And you can see that 60 meters will be the base of the triangles, and then the angles of 35 degrees and 42 degrees. So let's recall from the question above that the angle of elevation of T from R is 35 degrees. What that means is that if we stand at R and we look horizontal, then we will be looking at B. And if we turn our eyes slowly upwards until we see T, then that is the angle of elevation, which we have indicated in green. So what is the angle that we've turned? We've turned 35 degrees. Similarly, for P, we stand at R looking at B horizontally, and we turn our eyes upwards through an angle, and that will be the angle of elevation of 42 degrees. And finally, the right angle will be at the base RBT at that corner. Now part 2 says, calculate the length of the flagpole to the nearest meter, which is what we have in red. So how do we do that? If we look at the question, we can see two right angle triangles. Both of them have the same base, 60 meters. One is at a height of BT and one goes from B to P. And the difference between them is PT, the flagpole, which is in red. So let's extract the smaller triangle first, RBT. And when we pull it out, let's see what we have. We have 35 degrees. We have the base, which is the adjacent to 35, indicated as A. And we can find BT, the opposite. So this question uses two sides, O and A, and one angle. Thus, if we look at our formula, we can see that that is tan theta is equal to opposite over adjacent. And if we substitute, then we will be writing tan 35 is equal to opposite, which is BT, over 60. Now, let's cover off the 60 because we want BT alone on the right-hand side, and let's rewrite that. So we have tan 35 is equal to BT, and what are we going to do with the 60? We're going to take it, it's dividing on the right-hand side in the denominator, and when we carry it across, it will multiply. So it will be 60 times tan 35 is equal to BT, which gives us 42.0 meters. And if we look at what they require, they want our answer to the nearest meter. So when we are doing our working, we would like to go to one extra place, and at the end, we can round it off back to the nearest meter. So we don't write 42 meters, but we write 42.0. Right, let's extract now the second right angle triangle, the bigger one, PBR. And we know there's 42 degrees there. We know the adjacent, which is 60 meters. And we can find PB, which is the opposite, O. So this question, just as the other part, uses two sides, O and A, and one angle. So the formula we're going to use is the same. Tan theta is equal to O over A. And if we substitute, tan 42 is equal to PB over 60. We can cover off the 60 now. And let's rewrite what we have. Tan 42 is equal to PB. And we carry the 60 across, so the 60 will be multiplying. So we have 60 tan 42. Right? It's not necessary to write the multiplication sign, it's understood. So 60 tan 42 is equal to 54.0 meters. As such, we have the entire length PB and we have BT. So if we want to find PT, which is the height of the flagpole, then we take the longer length PB minus BT. And that is equal to 54.0 minus 42.0. So PT is equal to 12.0. And now that we've reached this point, now we round it off to the nearest meter. So the flagpole, PT, is equal to 12 meters. May 2021, number 3A. The diagram below shows the triangle PQR, in which angle QPR, which means if we are looking for that, look at the middle letter P, so it's the angle at P, is equal to 62 degrees. Angle PQR, and if we look at the middle letter again, the middle letter is Q, so the angle at Q is equal to 90 degrees, a right angle triangle, and PR is equal to 11 centimeters. Part 1 asks us, what is the size of the angle PRQ? So if we look at our solution here, understand that the angle PRQ, the middle letter is R, so that is the angle we want to find. So what do we know? We know that if we have two angles and we would like to find the third one, So if we add up all three angles, the sum of all the interior angles in a triangle is equal to 180 degrees. So we can substitute 62, because that is angle P, plus 90 plus angle R is equal to 180. As such, 62 plus 90 is equal to 152, plus angle R is equal to 180. So if I want angle R alone, I carry the 152 across. It's adding on the left-hand side. If we carry it to the right side, it means the additive inverse or subtracting, same thing. So 180 minus 152, angle R is equal to 28 degrees. And now that we know that, let's look at what part 2 is asking us. It's asking us to find the length of RQ. So let's extract the triangle. And when we redraw it, let's see, we have 62 degrees. We are interested in finding RQ. So RQ would be our opposite. And we have 11 centimeters. That is our hypotenuse, H. So since H is the longest side in a right angle triangle, that means our answer for RQ must be less than 11 centimeters. So this question uses two sides, the opposite and the hypotenuse, and one angle. So if we look at our trig formulae, we can tell that that would be sine theta is equal to opposite over hypotenuse. So when we substitute, sine 62 is equal to opposite, which is RQ, over 11. And we want to find RQ alone on the right-hand side, so let's cover off the 11 with our hands. And what happens? We write what we have. Sine 62 is equal to RQ. What do we do with the 11? The 11 is dividing on the right-hand side. It's in the denominator, so when we carry it across, it will be multiplying. So we'll get 11 sine 62. And we put that into our calculator and solve. And our answer is 9.71 centimeters. That is the length of RQ. This brings us to the end of our analysis of right angle triangles in trigonometry for the past paper questions, which was spread out over 2 videos from May 2009 to 2013, and this video 2014 until 2021. Stay tuned for other topics in which we will be doing CSEC solutions